He's talking about REST. Cool guy. Yeah. And well, take it away, Tommy.
Hi everybody, I'm Tom Haley. Today we're talking about RESTful design. So for our journey today, there we go. So today we'll be covering the basics of REST, and we'll also look at definitions. We'll also look at an example of how we use REST to communicate, and also talk about the challenges we face when trying to implement RESTful APIs. All right. So first, what is REST? So REST is defined by the systems of constraints and properties based on HTTP. So you might be familiar with like a website. So we also have to make sure that it's based on RESTful as a client-server architecture. So therefore, we're mostly covering, we talk about information sending from the server, us, to the client, somebody else. There's a uniform interface, so everybody knows how to use a website. So we always use the HTTP verbs in statelessness. And probably the most important part of all is that REST gives the client the ability to interact with our applications and our servers without having to get any information beforehand. So one thing we have to remember is there are things before REST. So REST was first thought up in like 2000 by Morgan. So we have things called RPCs. These are remote procedure calls. And it's kind of like taking a function and giving it like an endpoint URL. So there really weren't that many standards. You might see nice, fun URLs that look like that. Like create orders, view products. And that can be a bit confusing because when I look at an RPC request, I like to think about it as a lock. So there's our endpoints with RPCs, and we need to figure out how to make a key. So in this case, step one, we look at the documentation. Sometimes it's good, other times it's better. Step two, make a request. We build it, look at documentation, and then we hope it works. So, because people don't like to look at documentation, right? So one of REST's strengths is it allows a user to see what they can submit. So compared to RPCs, REST gives the ability for the user to look at the endpoints rather than look at documentation. I think it's really important for REST because it makes it easy for people using our stuff to work. So as our example, we're actually going to go and look at an e-commerce API we designed for this. Use the endpoints. So it's nice. It's got different versions. So we're actually going to make a request. So we actually first look at the endpoints, and it's going to give us all these different paths that we can access. These are different paths that we use. We have cards, with products, just like a website, right? These are links. And we know here's a request. So we got here's the action, something we're doing, a resource. Actions are verbs that do things. In the rest, we only have 7. I don't like the names, so we're going to rename them. So we got, I sort of a request. I like to think of it as when we look at something, post, yeah, where does it make something, kind of build it. Then we also got this put and patch. They're slightly different. Put is used to swap out the entire thing, where patch is just to edit a little bit of the thing. And of course, delete. So then, we have resources. So resources are nouns, and nouns represent stuff. So in our case, we got actions. We can say, hey, we can look at products. Okay. And then, so we look at URLs. We can actually illustrate them as different nouns and verbs. So we can actually look at different things. Let's go to a toy store. We go to the products, and then we see that there's a teddy bear aisle, and we can also see that in the teddy bear aisle there are toys. So that's resources. So everybody knows our resources now. And everybody knows how to make a request, right? So in this case, the client makes a request, it hits our endpoint URL, and then something happens, and we get something back as a response. So of course, responses have two things. They got the headers have a status code, and then we have a body. So these bodies can have can return anything. It could be just JSON, XML, plain text, whatever. And then the status codes kind of tell us how our request went. In other parts of REST, we can also include different instructions for the client to do. I'll cover that a bit later. So status codes, you know, with the basic idea of what we should do. So if this is hard to remember, I got a picture that reminds me who messed up. So here we go. So 200. You know, 200s are pretty good, so that's great. 300s, it's somewhere else. 400, it's your fault. 500, my fault. So to explain the other different actions of REST, we're going to go through an example. So we're going to go to the toy store. So this is Joffrey's Jaguar. And we're actually create a wish list for children. So here we go. So to create a wish list, of course, we have the wish list endpoint API, Santa. And when we build a wish list, it's going to tell us that we've created a status, created something, and give us location of where our wish list is. So then we can look at it. We got a nice pretty wish list. And then we want to add items to a wish list. We can just pick a car, we then add it to an endpoint. In this case, our wish list had a cart. So we can just build the cart, add items, and it tells us in this current API that we have in our cart one car, quantity 2. That's what we wanted. We can do that too. So each time we hit the API, we can add more things to the cart. So here we go. We want teddy bears, and let's say I want another teddy bear. I submit it again, and here are more teddy bears. Let's say that we didn't want a teddy bear, and we'll just change our mind. We want a pony, toy pony, so we can do that too, using a put request. Let's say we want some more for everybody in the family, so I want like 10 teddy bears, 10 unicorns. That's patch. And let's say Dad said there's too much money, so then no teddy bears, no unicorns, just get the car. And that's basics of REST, right? Well, we run into a lot of different challenges when building REST, and some of them are like this. So a lot of times when we try to design REST things, we only have like 5 verbs to use. So we run out of verbs, and we try to do stuff like this. So we kind of take a verb, and we add it to the end of our nouns and sources. So this is pretty practical for us to use as a programmer, but it's not really consistent because we have nouns, and then we got a verb. And that's, you know, makes it harder for the client to expect what we're looking for. So sometimes we can do, oh, hang on. Okay. Well, that's number 4. Number 1. So in this case, we want to look at something and we want to buy it, right? We go to the store and we point out an item. It's called free, right? So get is what's considered a safe operation. You can always look, but never touch. So make sure when we're designing our APIs to, in this case, we look at the wish list and want to buy it. But we probably should do like a post instead. Manipulate that. Another problem is sending this wrong status code in the response. So, you know, a lot of ASM APIs, they design it, they give like an error code so everything's good. So we look into the response, and, you know, we get a nice big fat error in front of it. So, so probably we should be more consistent for our user and our clients to send the right information to them. Okay. Another one is keeping the stateless server. So REST is supposed to be stateless. So what this really means is the server doesn't really know what the particular user is doing. So a pretty good example of that, I think that is like paginations. So paginations, you It might be nice that we have like a list of products, and then we have like a next URL to send them to the next page. But right now, that the server now has to manage the state. Instead, it's pretty common that we pass in maybe like a page parameter for a number of pages. So now the second page. Oh, right. So back to number 4. So sometimes when we have a hard time figuring out our verbs, we try to make our verbs into nouns. So instead of recommend, we have recommendations. Layout, instead of making it to those layaways. Yeah. Make them, we try to do it this way. Other times, this is not really that easy. This is, I think, the hardest part about REST is trying to describe what we really want to do. Because we get things like this, where we have an object in our URLs, and has a lot of state changes. Like in order, we have we process it, we can fulfill it, and I only have 5 verbs, and most of them are pretty taken. So this is a common issue. Another one would be like there's some things that are really hard to describe as verbs or nouns, like search. Searching is an action. So what do? One thing we could do is we can write better documentation so they can have them to read it. But another way to try that would be maybe we just take the instructions and then we send it to the client. So on top of just making a request or making a request, we also package in like a set of instructions. Okay, you can go visit here to do what you need. This is a concept known as AOS. Hypertext is as the engine of application state. It's not really catchy to say. For this part, we don't have to, so part of REST is we want to make sure there's the client has as little expectation as possible. They can figure out what to do on their own. So AOS is a way where we actually bundle up meta information so that they can use our app better. So in our example, we would send over, so we can send over maybe a set of links that tells them you can visit here to do stuff. And then there's cases where you probably should use REST. It's not the best, it's really good for what it is, but there are some cases where you have issues. One of the issues we have is maybe like a mobile bandwidth limited customers, like mobile apps. REST is really maximal, so we try to send all the information out at once every single time. So you may want to consider using something like a GraphQL or adjusting your parameters to just send only a certain amount of fields. Other things would be if your data domain has a lot of action-based things, maybe it's better instead of trying to make nouns as verbs and actions, we just match it up and do an RPC style thing. And yeah, I think that's about it. Thank you. Questions? Yes.
You would say that if you were building an application that did more than just the standard verbs, you wouldn't use REST?
I would try my best to find ways to make it taking those verbs and making it into some kind of nouns. Because a lot of things, like maybe like order that process, right? We actually might be able to spin this order out into a separate process where we're actually seeing the process of our order as it goes along. But for the most part, since REST is mostly used for showing the client what to do and how to interact with our stuff, I try to keep it as consistent as possible as what their expectations are. So if it's all going to be, is this going to be like a new product or an existing product? I don't know.
Pretty well existing.
Well existing. I try to keep everything pretty consistent. So if it's mostly REST at first, try to make it mostly REST. But sometimes it's hard. Keep it pragmatic. Make it easy for everybody. And if you have to, make it RPC. Yes.
So when you're doing, I like to call it videos, sort of breakfast cereal.
Okay.
Where do you put the links?
The links. So that's a good question. It depends. I guess a lot of people have like a data envelope, so it's like a little piece of thing saying, "Hey, here's your information." Underneath it, if you make like would have like your links in there. So I could probably see maybe just restructuring all your responses that way. Probably the best idea. That's a good question. Next question. Yeah. Yes.
Does anybody ever actually implement that?
AOAS, that's a tough question. Raise a hand for AOAS lovers.
Yeah, if you want to try, if you want to see like some practical uses that GitHub actually uses for everything as well, it makes it really nice when you're going through and like working with a user. You don't have to like hard code links anywhere.
So the idea that the developer is using their leads the responses and sees the links, or that's how they run it.
Yeah. Well, that's how they learn it. That's also how they could use it as well, like actively.
Yeah.
Other examples, I think I know PayPal does a AOAS API, so you can actually make a request, you can actually see what's going on.
Yeah. Check out the JSON API.
That's a good question. I don't think many people really implement AOAS because it's really hard to know what's going on at the time. Yeah. Yes.
If you're leveraging patch and two different consumers of your API both pull down a representation, but then they try to change two different pieces of data in that representation, how do you handle that sort of change?
Wow, that's a good question.
Transaction.
So hopefully we have a transactional way of making sure one changes the other first. Maybe find a way to queue up all the patches together, and then whoever is the last person that patches wins. That's what I would do.
Only use post.
Or just only use post and
Stop whoever changes it before you do.
But
I've seen people do.
But most of it is just like we're talking about the interface between the client and the server. So how we actually run in the background could really change depending on what we're going to need to. A lot of times, these patches you just send up, we just queue it to another server that eventually updates later. Yes.
What is the
GraphQL. You should go to the next talk. Come back next time. But from my understanding, GraphQL, I don't understand GraphQL. I haven't read that much into it. I want to read the definition. There are some issues I have with it where if you have an error with GraphQL, you send a 200 request, which I think is stupid, but that's part of the spec that I read. But give me please, any GraphQL people that know? Yes.
What were you asking?
Oh. Am I wrong to rewrite the application of GraphQL? It said send a 200 request even if there's an error.
There are different schools of thought.
Okay.
If the network layer works, it's a 200.
Good point.
You got something back. It might be an empty object, but you got something back.
Okay. All right, does that answer your question? No. All right, yes.
If you're working on a system where there's only like a few people working on, actually it doesn't matter how many people, but the same people are working on the front end and the back end. Really, you're writing the front end that consumes your API.
Mm-hmm.
What are the arguments for trying to keep RESTful in that case?
Well, I guess we're not just working for your current team, maybe like a future team, possibly. Sometimes maybe our projects will be inherited by some other people. I'm an expert at inheriting projects. And sometimes when we look at it, we say, hey, this is consistent. And then we have this weird little kink in our brain because somebody decided to try to break out of it. And although it's pretty easy to see what they're doing, but all these extra kinks along the way makes it even harder for us sometimes to understand what's going on. If your team is small enough and your product is, doesn't really need to be all RESTful, feel free to break out because, the main goal is to make something work and not just make something RESTful. Right?
That's what I read all the time.
You have a couple people.
That is true.
In the context of some of these data repositories, when you push data into the cloud, things needs one of them first to try and get material. And you can push and retrieve data from, and it makes it super easy for dumb clients like microcontrollers to interface to your API. Because all they need is basically a client to
very attractive.
Oh,
Oh, okay.
Internal between you own the client, you own the server, there's much more trade off about, do you want to eat the over there or that, or do you want to make your own customers?
Right, to repeat, yeah, we look at public, so what the gentleman said was, which is really useful for public APIs. For maybe small internal teams, maybe not, do whatever you want. Keep it RESTful, please. Yes.
Don't you still need documentation for a REST API? Because you have to say what kind of like bodies you can send in requests and things like that.
That's a good question. It would be nice. We should always have documentation. That's answer one. Sometimes you can actually look at an existing GET request, and then when you grab an existing GET request, you can also automatically see what the different fields are for posts. Because if you get something, you should be able to post the same thing back. So it kind of makes it easy, you know. So I don't know what the shape of this thing is. I just look at requests on existing thing, and hey, there's all my fields. But yeah, documentation is good. Yes.
That's if the REST API you're working with actually follows conventions.
Oh yes. Yeah.
Yeah. It's not my experience in most cases, unless you know with like a well-known API, like a big power or something like that. But internal teams, like good luck.
You got me. Most of my REST APIs aren't as pretty as the things I was showing. I'm trying to make it work because communication is important between clients, and as I work with integrating multiple services and other different vendors and stuff, it's nice to have some consistency between their own damn stuff. So, any other questions? All right. Well, thank you very much.